Let's look at this equation. Y is equal to ln of x plus square root of 1 plus x squared. And we are going to find its first and second derivative. Begin with the first derivative. There's nothing that we can cancel out. There's nothing that we can simplify in this ln expression. This is an addition. We cannot break down ln of a sum. Okay? I wish that this was a multiplication. If that's the case, the question would be much easier. But this is pretty cool as well. Okay, ln of something, when you take the derivative of that, you begin by writing down 1 over the same exact thing in the denominator. So 1 over x plus square root 1 plus x squared. And then you have to do the chain rule. Look at the inside. I'm going to multiply by the derivative of the inside. Derivative of x is equal to 1. And then for the second part, I have the square root. Let me put on the addition first. Derivative of the square root is going to be 1 over 2 square root of whatever we have inside. So 1 plus x squared inside of the square root. However, we look at the inside again, inside of the square root in this case. To get the derivative of the square root of 1 plus x squared, we also have to use the chain rule for that. Multiplying the derivative of 0 is 0. Derivative 1 is 0. Derivative of x squared is 2x. So I will have to multiply this part with 2x. And that's the calculus part. ln of something, you put down 1 over the same thing times the derivative of the inside. Derivative of x is 1. Derivative of square root of 1 plus x squared is 1 over 2 square root of 1 plus x squared times 2x. Just like that. And the 2 cancels out. That's very nice. And let me write this down right here. This is going to be 1 over x plus square root 1 plus x squared. Inside here, what we are going to get is, let me open the parentheses. I have the 1, and then I'm going to add that to cancel out the 2 already. I have the x on the top over square root of 1 plus x squared. And here's the thing that we can do. 1 plus a fraction. Let's combine fraction to see what happens. I will need to have the common denominator here. So this right here, I will have to get square root of 1 plus x squared. I will have to do the same on the top. Just like this. So this will be 1 over x plus square root 1 plus x squared. Inside here, because they have the same denominator now, I can put this down as square root of 1 plus x squared in the bottom. On the top, I have square root of 1 plus x squared and then plus x. Guess what? This and that completely cancel with each other. And then we are going to end up with just a 1 on the top over square root of 1 plus x squared. And this right here is the first derivative for this expression. And now to get the second derivative, this is what we do. Y prime, we know this is going to be that. It's 1 over square root of 1 plus x squared. However, we can look at square root as 1/2 power, but it's in the denominator, so what we need to do is bring that up, and then we can look at this as to the negative 1/2 power, and then we have the inside 1 plus x squared. So look at this form right here. Take the derivative, and we can get a second derivative. Bring the power to the front. So bring the power to the front, and then minus 1. We are going to get negative 1/2, and then here I'm going to have 1 plus x squared. The inside stays the same. On the top, negative 1/2 minus 1, that will be negative 3/2. We are not done yet. We have to look at what's inside of the parentheses and take the derivative of that. Derivative of 1 is 0. Derivative of x squared is 2x. And now I can put things all together in a nice way. the 2's cancel out, and I can bring this down to the denominator. I have an x on and a negative on the top. Negative x on the top over this down to the denominator, which is 1 plus x squared raised to the positive 3/2 power. This is okay. Well, sometimes what we can do is the top is still negative x, but then the half power right here becomes a square root. I can rewrite this as the square root and use parentheses 1 plus x squared and then to the 3rd power. Either way, perhaps I will box this one. And this right here is the 2nd derivative. That's it.